Okay, guys, today we're going to be looking at Lesson 11, and Lesson 11 is a lot like Lesson 10. Yesterday, today, we worked on finding the area of rectangles, and usually one of the sides was a whole number, and the other side was a mixed number or just a fraction. And today, if you look at our objective, it says that we're going to find the area of a rectangle with mixed by mixed and fraction by fraction side lengths. So that means that we're going to do the same thing that we did, but instead of having a whole number, both of our numbers are now going to be mixed numbers or just fractions. So today was building that foundation for what we need to do for this lesson. So go ahead and get your objective written down. Today's lesson is in your problem set. So you should have your problem set out and you can be working it as I am working mine. So I went ahead today and I filled in this as I was waiting here for everything to load. So that way you wouldn't have to watch me move all of it. Don't worry, you get to watch the rest of them. And so this is rectangle A. So I started with my whole tiles and I built all the way up. Now, yesterday, I think part of my confusion was that I just forgot the basic formula for area. And today I noticed that a lot of you are still struggling with that formula for area. So if you remember, the area is that blue inside part of the rectangle. And I find out how much I need to fill that area, which is just a two-dimensional shape, so just a flat rectangle, by multiplying the length times the width. So I went ahead and I've drug my tiles over. And for this one, I'm going to say that my length, if you notice, this was my hole. And so I used two of those. And then I had a half that I flipped over. So down here, if I'm looking for my formula of area equals length times width, then here my length is 2 and 1/2. Okay, so I've got that started already. So I'm going to go ahead and I'm going to put that here, 2 and 1/2. Now, I've looked across the front, so now I need to look at how kind of deep it is, so to speak. So this is my length. Now the width is going to be this way. So I've got 1 hole, 2 holes, 3 holes, 4 holes, and then you can hopefully just visualize that there. I had a half. So this side is going to measure 4 and 1/2. All right, so now my job is to multiply these two numbers. So yesterday we did a really confusing method where we busted it into partial sums and then we put the fractions together. And I think that that really confused a lot of you. So when I was working with you, I started very simply just going back to what you know about multiplying mixed numbers. And so that's how we're going to approach this today. So we're just going to look at these as we have two mixed numbers that we have to multiply. And I know that anytime that I'm working with mixed numbers, I need to take that mixed number and I need to turn it into an improper fraction. So this is where my paperclip comes in. All right, so I have 2 times 2, which is 4. And then I have to add that 1, which gives me 5. And my denominator stays the same. And then here, I have 4 times 2 equals 8, plus 1 equals 9. So that is a trick, but let me show you why that trick works. So if I have 2.5, then that means that I have 2 holes, right? So like I have this and I have this, and then I have this. Okay, that would be the picture representation. So if I cut it all into halves, then that means I have 1/2, 2/2, 3/2, 4/2, 5/2. So that is why the trick works. Or I could say that if I'm talking about a denominator of 2, 1/2 would be 2 2s, right? That would be 1/2 plus 1/2 plus 1/2. And I would get 5/2. So the clip method is a trick that we use, a shortcut, if you will. But this is why the clip method works. So now that I've used the paperclip method and I have found my improper fractions, I am going to multiply straight across. 5 times 9 is 45. And 2 times 2 equals 4. So now I could do this a couple ways. I can say how many times does 4 go into 45? That would be 11, because 11 times 4 equals 44. So it's like if I had 45 little blocks like this. Remember when we used to do this? And I was making groups of 4. How many groups could I make? Well, I could make 11 groups of 4 with those 45. And then when I'm done, I would have 1 block left over that didn't have a home, 1 block out of the 4 that I would need. So that's where that number comes from. Okay, that's how we take that improper fraction and turn it into a mixed number. The other thing that you can do is you can keep pulling out wholes. So if I have 45/4, I can pull out, take away 4 minus 4, which is 1 whole. Now that is not the most efficient way to do it because I would have to do that 11 times before I got down to where this was a proper fraction. So I'm not going to do that, but that's another way of doing it if you have smaller numbers that you're working with. So my area for rectangle A would be 11 1/4 square. And so if I look at my holes, I have 1, 2, 3, 4, 5, 6, 7, 8. Here's a half plus a half, that's 9. A half plus a half, that's 10. Half plus a half, that's 11. Now, so how do I get that quarter? If you notice, oh, I did it down here, sorry. If you notice, this one here is about half of a half. Okay, so see, there's the half. See how it kind of slides in there? So half of a half, half times 1/2 equals 1/4. So counting them, you can count them that way to find the area, but you've got to be very careful with the placement of your blocks. I had stuck that in the wrong place. I meant to stick this one over top of this one so that way we could see that a little bit easier, but it was hiding in there. So Caleb Hannon, I know that you're watching this, and I know that you can see that that is half of a half. All right, shout out, my man. There it is. Okay, so let's take a look here at rectangle B. So I think rectangle B, we're going to look across. The first thing I have to do is I have to find the length and the width because I'm trying to find the area. So I'm going to start with my hole. I'm going to say 1. I'm going to go ahead and I notice right away that that is not going to fit. So I'm going to see if I can get, oh, look. Whoops, this is close. A little shaky. There we go. 1 and that block was 3/4. So my length for this rectangle is 1 and 3/4. Okay, sorry, that's running out of room. Okay, so now I'm going to figure out what my width would be. So I have 1, I have 2, I have 3. All right. Hopefully you can look at that and you can visualize. I am not going to be able to get another hole on that. And a half, that's not big enough. So I'm going to try my 3/4 again. And I'm going to see. And that fits perfectly. So I have 1, 2, 3 holes and 3/4. Okay. So I've represented it with a tile. And now, get some more page here. We're going to work the math. So I have 3 and 3/4 times 1 and 3/4. Now I know a lot of you are trying really hard just to multiply these whole numbers and then multiply the fractions. And while I wish that that was a shortcut that worked, it doesn't work. You will not get the correct answer for whatever reason. I could go into it, but I don't think that you all need to hear all that right now. What I need for you to remember is just that we need to turn this mixed number into an improper fraction. So I have 3 whole 4/4. So that would be 3 times 4. That would be 12. And then I have 3. So 12 plus 3 equals 15/4 times 1 times 4 equals 4 plus 3 equals 7. I've noticed that these numbers are getting higher and higher. So I could probably do this in my head, but I'm going to, just for the sake of making sure I'm correct, I'm going to take that extra step and make sure that I have that right. So 35. 7 times 1 is 7, plus 3 is 10. So that gives me 105 over 4. So now if I have 105 blocks and I'm making groups of 4, how many groups can I make? Well, I'm going to go ahead and I'm going to break this out like some long division. 105 divided into groups of 4. So if I have one block, I cannot make. Okay, so if I have one block, which would be like the hundreds map, I can't make a group of 4 out of that because that is one solid block. But I can take that hundreds block and I can break it down into 10 tens. 3, 4, 5, 6, 7, 8, 9, 10, right? And I come over here to my number and I don't have anything in the 10 spot already. So I can just look at these 10s and I can say, oh, well, I can make a group of 4 there and I can make a group of 4 there. So I can make 2 groups. So I'm going to come over here because I'm working in the 10s. I made the groups out of 10s blocks. So my 2 goes there. And when I made those 2 groups, I actually ended up using 8 of those 10s. So there's a group of 4 here, a group of 4 here. That's 8. And I had 2 left over. All right, now, because I have these 2 blocks that can't be made into a group of 4, I can take those and I can break them down into ones blocks, those one little squares. So I'm just going to kind of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are those 2. But then I come over here and in my original number, there was already 5 ones. So I got to put those up there. 1, 2, 3, 4, 5. And now what that means is that I have 25 ones. So remember when we do long division and we always say you have to bring the 5 down? Well, it's because what you've really done is you've broken those 10s into 1s, but you also still had 5 ones in your original number. So that's all that you're doing. So now I can start making my groups of 4. So I can say there's 1 group of 4. I can say there's 2 groups of 4. I can keep going. But I'm going to get 6 groups of 4. Okay? And when I do that, I will use 24 blocks. And there will be 1 block left over. All right? So 4 goes into 105 26 times. I can make 26 whole groups, and there would be 1 left over out of the 4. Okay? So that units, that is the area of this rectangle. It's the length times the width. There's a lot of steps that I have to take to get to there, and that's okay. That's what you're supposed to do. This is a review of all of those skills that we've been learning all year and building on those skills that you've already know how to do. So let's go ahead and try rectangle C. Oh, a small one. That's nice. All right. So I can tell you already that 1 is not going to fit. So I'm going to see. Let's see what happens if we turn it. Ta-da! That fits. And then just by looking, let's see. One of the things that I am noticing is that these blocks, these rectangles, don't exactly match up. So maybe it's not half. Well, that doesn't seem right either. So it's supposed to be, this is supposed to fit. I don't know why it doesn't. I guess the people that made the slides kind of goofed that up a little bit. But in your book, when I'm looking at your book, if you look, it just has that spelled out for you a different way. So in your workbook, what we're looking at is that we have 3/4 and 1 1/2. I'm not sure why the rectangle looks so different on here as it does in your problem set, but that's what it should be there. So I'm going to go ahead and multiply 1 1/2 times 3/4. So I have a mixed number by a fraction. I cannot just multiply the fractions, friends. I cannot. I got to change this. 1 times 2 is 2, plus 1 is 3. Let me get myself a little bit more room to work here. So 3 halves times 3/4. All right, I multiply straight across. I get 9/8, which gives me 8 goes into 9 one time. There would be 1 left over out of the 8. So my answer would be 1 1/8 units squared. So what I'm noticing in your drawings here, or that they're wanting you to do in your book, I'm going to kind of maybe forget about this right now, and I'm just going to draw it for you. Okay? So it tells you that here is, this is rectangle D, and so we have 3/4 times 1/2. All right, I think that's what you're looking at in your workbook. So I'm not even going to use the blocks on this one because that seems to be a little bit confusing. The rectangles don't seem to match up. So now I'm just going to multiply length times width. So I have 3/4 times 1 half. So 3 times 1 equals 3, and 4 times 2 equals 8. So my answer is not a mixed number. I didn't work with any mixed numbers. So remember, when you multiply a fraction by a fraction, the number actually gets smaller. So it makes sense that there is no whole number there. So my answer would be 3/8 units squared. All right. So we do have rectangle E here, which I don't see in your book. So let's go ahead, and since I don't have the measurements for that, I'm not going to work this one for you because that's not in your problem set. So let's go ahead and take a look, though, at number 5 in the problem set. I'm going to go ahead and go to a blank screen because I don't have this in my slides. And so it says, Colleen and Caroline each built a rectangle out of square tiles placed in 3 rows of 5. All right, so they're going to make a rectangle. They're going to make 3 rows of 5 squares. So we all know that Miss Pipkin's not a good artist. Oh, you know what I could do? Because I'm on my smartboard. All right. And then I can clone that. So 2, 3, whoops, 4, 5. Let me make those a little bit nicer there. All right. And then she's going to make 3 rows of that. Whoops. So, whoa, what happened there? 1. Well, I thought I was going to clone that. Nuggets. There we go. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, wrong one. 4. 4 and 5. All right, so it's a little bit messy, but that's my rectangle. So tidy that up just a little bit. It doesn't have to be perfect. And if you're drawing it, it doesn't have to be perfect. You just need to kind of know the dimensions. Okay. So I have my pen here. So Colleen and Caroline each built a rectangle out of the square tiles placed in 3 rows of 5. Colleen used tiles that measured 1 2/3 centimeters in length. Caroline used tiles that measured 3 1/3 centimeters in length. That means each of these sides, because it's a perfect square, each of these sides are 1 2/3. So it says draw the girls' rectangles and label the lengths and widths of each. So let's just go ahead and say that this is A. All right. So I have my 3 rows, right? 1, 2, 3. On Colleen's, I wish they weren't both a C, so we'll call Colleen CO. So on Colleen's, she has 3 rows here. And each of those rows measure 1 2/3 because that is the length of that side. That's 1 2/3, that's 1 2/3, and that is 1 2/3. Okay, so 3 times 1 2/3. Now, down here, I have 5. 1, 2, 3, 4, 5 times 1 2/3. So before I can even find the area, oh, it doesn't even have to on part A. It just says to label the lengths and widths of each. So then I would do the same thing for Caroline, and I would draw her rectangle. Let's just kind of make that a little bit. 3 times, hers are 3 1/3. And here she would have 5 times 3 1/3. Now I didn't put the blocks in, but it's the same exact shape as this. I'm just leaving the blocks out and I'm just using the numbers, okay? So then part B, it says, what is the area in square centimeters of the girl's rectangle? So I know it's length times width. So that means I know it's length, or well, this is width, but whoops, 1 2/3 times okay, because this is the length, this is the width. I got them backwards there, but that's okay. I can do that. All right, so before I do anything else, I have to convert this all to fractions. So I'm going to take that 3 and I'm going to put a 1 under it because the order of operations tells me I have to do what's in the parentheses first. 1 times 3 is 3 plus 2 equals 5. And I'm just going to keep working my way down. I'm not going to jump in and try to solve a bunch of things at once. On my first row, I'm just going to turn them all into fractions. 1 times 3 is 3, plus 2 is 5. All right, now I can multiply. 3 times 5 equals 15 thirds. I'm going to multiply over here by the other side. 5 times 5 is 25 thirds. That was inside the parentheses. And now technically I'm done with the parentheses, so I can drop them. So I'm going to do that, and I'm going to go ahead and I'm just going to do the math on this. So 3, no, actually I'm not going to do the math on this yet because I would turn them into mixed numbers to be multiplied. So I'm going to leave them as improper fractions. But what I am going to do is I'm going to cross simplify. I'm going to say 3 goes into 3 one time, and we're going to make that 3 goes into 15 5 times. So I'm going to simplify before I ever do the math because otherwise that might be difficult. So 5 times 5 times 25 equals 125 over 3. So that is now my answer, but I can't leave it like that because it's improper. So 3 goes into 125. Divide. 3 goes into 12 4 times. Bring down the 5. 3 goes into 5 one time. So I would make 41 whole groups. And I would have 2 thirds left over. That is the area of this square, of Colleen's square. I would do the exact same thing for Caroline's square. And then part C, I would compare. I would tell which one's greater than, which one's less than, whose square is bigger than, whose square is greater than. So if you want to finish that and bring that in to me tomorrow and show it to me, I will give you a Grover Gotcha and a Class Dojo bonus of 5 points for taking the initiative to do that extra work. Otherwise, when you come in tomorrow, make sure that you are ready to hand me the homework, number 1, A, B, C, D, E, for lesson 10, and be prepared to work on lesson 11. If you can, comment below that you were logged in and you watched it, and I want you to write the word peanut. So for example, if I am Carter Nooner and I'm watching at home, in the comments, I'm going to write Carter peanut. And that way I'm going to know that you watched it all the way to the end. And there might be some bonus points in there for you for that as well. So, and Carter Nooner, also be thinking about what you want with your Class Dojo points. You want to chew gum, you want to wear a hat, you want to have lunch in the room, You want some extra recess time. You figure out what you want to do with your Class Dojo points. So you guys have a great night. Come in tomorrow with your questions. I'm going to go over your exit tickets with you tomorrow and cover anything that I feel like we might be having some trouble with. All right, don't forget your Chromebooks. Have a great night, and I will see you tomorrow.